This video is on density. You'll recall that density is defined as the mass of an object divided by the volume of that object. So if we wanted to make something less dense, we could decrease its mass or we could increase its volume. The density of fresh water depends on the temperature. So in this plot, we've plotted temperature on the bottom axis there in degrees Celsius from -2 degrees up to around 22 degrees. And then on the vertical axis, we have density in kilograms per cubic meter. You'll notice that there's a break in the vertical axis. So down here, the tick is at 917 kilograms per cubic meter. And then suddenly it jumps to 997, 998 kilograms per cubic meter. The reason for this is that ice is a lot less dense than water, liquid water. So ice has a very defined, well-defined lattice structure to the molecules, the H2O molecules. And so it has a density at 0 degrees around 917 kilograms per cubic meter. If that ice was then to melt into liquid water, but still at 0 degrees, it would become a lot more dense and have a density of around 999 kilograms per cubic meter. Then if we were to continue warming the water, as we head up towards 4 degrees, the fresh water will get denser, and at 4 degrees, it has its maximum density of 1,000 kilograms per cubic meter. Then as we continue to warm the water, it would start to get less dense again. The density of seawater depends not only on temperature, but also on salinity. As you can imagine, the density increases with increasing salinity. This is because we're adding salt, so we're adding some mass to the same volume of water. So the more salt we add, the denser the water will become. The bottom line on this plot, again, it's a temperature on the bottom axis, density on the vertical axis, and the bottom red line is fresh water that we've just seen. And then we have increasing salinity as we go higher up the plot. You'll notice that a couple of things change as salinity increases. One, the temperature of maximum density decreases. And two, the freezing point decreases. So fresh water has a maximum density at 4 degrees and a freezing point at 0 degrees. By the time we get to a salinity of 24.7 grams per kilogram, the maximum density is now at the freezing point. By the time we get to 35 grams per kilogram, the maximum density is still at the freezing point. And now the freezing point is around -2 degrees Celsius. This is what's known as a TS diagram, or temperature salinity diagram. So you'll see that on the vertical axis is temperature, and the horizontal axis is salinity. And the green lines here are density contours. So up here we have density of 1,021 kilograms per cubic meter, and then as we come down on the diagonal, the density increases, and here now the bottom line plotted here is 1,029 kilograms per cubic meter. So you can see from this plot what we just talked about, as temperature increases, the density decreases. So this line is around 1,026 kilograms per cubic meter. As temperature increases, we go to up towards this 1,021. As salinity increases, the density increases. So here we're at around 1,026 again, and then we increase salinity and we head up towards 1,029. So typically seawater is in the range of 1,020 to 1,030 kilograms per cubic meter. So one interesting thing about seawater, which is very obvious when we do this TS plot, is that water masses or water with different temperatures and salinities can actually have the same density. So here I've plotted 2 dots on this 1,025 kilograms per cubic meter line. So this one is much fresher and colder, and then this one has exactly the same density, but it's much saltier and it's warmer. And we could do the same with any of points in this diagram. So what changes density? Well, it changes in either temperature or salinity. So let's start with what changes temperature. Well, this is a plot of the surface temperature of the ocean, and it looks very much like you would expect from the solar radiation discussion we had earlier. Highest radiation per unit area is in the tropics. So you can see the reddy colors are all in the tropics. And then as you head towards either pole, the temperature decreases. And this is the same as what we saw with the amount of solar energy at the poles being spread over a much larger area. Primary thing setting temperature is the absorption of sunlight, which adds heat, and then cold winds and evaporation remove heat. So primarily temperature throughout the ocean, even at depth, is set at the surface. So you have temperature being set at the surface and then that temperature water sinking and becoming part of the deep ocean. The pattern of salinity is quite different from what we've seen before. So we have high salinity, so the red colors, in a couple of blobs, one in the North Atlantic, one in the South Atlantic. There's also high salinity in the North and South Pacific, and lines of low salinity around the equator. What's setting this? We can decrease salinity by adding precipitation, so snow or rainfall, which is adding fresh water to a particular volume of water. So you're diluting the amount of salt in it, so you're reducing the salinity that way. And if you evaporate, you're subtracting fresh water, so you're increasing the effective amount of salt in that volume of water. So over here on the right, we have a plot of global mean evaporation minus precipitation. The greeny colors down here are where precipitation exceeds evaporation. So right along the equator and in the polar regions. And you'll see that's where we have the more bluey colors, the lower salinity in the salinity surface plot over here. And then in the mid-latitudes, we have that evaporation exceeds precipitation. So there's more evaporation than there is rainfall. And this is where we have the high salinities. Looking at this in a zonally average, so by latitude average, so on the vertical axis here, we have latitude, the equator, the southern hemisphere, and then up to 80 degrees north. So you can see that at the equator, we have low evaporation minus precipitation. So we have excess precipitation, and we have low surface salinity. In the mid-latitudes or subtropics, we have more evaporation than we have precipitation, so we have high salinity. And then as we get towards the poles, we have more precipitation again. And then there's this sort of local maximum here where we have an increase in surface salinity, and that has to do with the high salinity that comes with the formation of sea ice. Ice, as I mentioned earlier, has a very well-defined lattice structure. So when ice forms from salt water, it actually rejects the salt. So you have high salinity water coming out of the ice, and you have pure water more or less in the ice.